Hello and welcome. My name is Aoudi, and in this lesson I will explain the rules of data flow diagrams. A data flow diagram, or a DFD, is simply a way to visualize what the system does. It is important to differentiate between what and how. DFDs do not explain how the system works. Okay, so basically DFDs represent a model that describes the data and processes of the system. We usually start with the system requirements, is something we already collected, and knowing the rules of DFDs, we can translate into what we know as the logical model of the system. There are different conventions to create DFDs. I will be explaining the Gain and Sarsen method. And basically we have 4 symbols. The process, which is basically the most important thing in a DFD because it requires that you know what the system does, and each process is basically a process of that system. Of course, data flows are also very important because they provide processes with inputs, and then the outputs are also data flows. And if we need to store any data temporarily, then we use data stores. And finally, the last symbol is the entity, also called an external entity, because it's something outside the system that interacts with it. Alright, we will start with the process. And the process, like I just said, is an object that produces an output based on a given input. Now, it's important to understand that the output is very different from the input, otherwise there is no need for a process. If we look at the symbol itself, we realize that the name of the process is written as a verb followed by a noun, so it would always sound like do something, as the example here, find student. The compartment above, which has the number, is basically the number of the process, and in different lessons I will explain this, but for now there is no order in a data flow diagram, so 1, 2, 3, 4 doesn't really matter. It's just that it's a number to uniquely identify the process. Processes don't mean anything without data flows. In fact, that's why the diagram itself is called a data flow diagram. The data flow, which is the arrow, is basically a path for the data to move through your system. So if I have a process find student, then I need to ask myself, what is the input that I need to perform this activity? Again, I don't care how it's performed. All I need to know know is what it does, and therefore I need something like a student ID. So the data flow itself, it's a pipe where the student ID will go through into the process itself. The process will do something, which is basically to find the student, and provides me an output, and that output is a student details. Again, this data or this information will go somewhere else in your system. Let's take a look at some examples of processes and data flows. All of these examples are okay, they're correct in terms of rules. First process is register user. So basically, again, it needs an input and it will produce an output. The input that I need to register a user is the user details, the information of the user. For example, the name, the address, the phone number. You realize that it's a collection of many pieces of data, but I can combine them in one data flow, which is user details. What do I produce? After I do what I have to do, which at this point I don't need to understand how, but at the end I need to know that the user is registered. So the output of this is the registered user. Another example is to find business. So it's a search process or function, and to do that I need two inputs, the business name and the city where that business exists. Again, the process will work and produce the search results. It could be 1, 2, 3 or many businesses with a similar name. Another example is upload video. Let's say I have an online site like YouTube where I can upload videos. The input is the video file itself. Now notice here it's not really data, raw data, it's an actual file, it's a physical file, and that's also acceptable. The process will work. So before the upload video, the video file was on your computer locally, and after that what happened is that the video is uploaded, so it's available somewhere on the server, but you also get a notification. So this process is producing two things, two outputs, and that's also acceptable. Let's take a look at this example so we can build on it. So the upload video took the video file, it produced a notification. It could have been an email notification or just a web page notification, and there's the uploaded video. I can take that output and then put it as an input to another process, which is process video. Now notice here the word process is a verb, process the video. Okay, so now that the video is on the server, it could have been uploaded in AVI or WMV or different formats, but in order to display it I need to have it as a flash video or FLV. So this process will do its thing, and when it's done it produces the output is that the video is now available for viewing. And in YouTube this actually takes sometimes 10-15 minutes. These are incorrect examples, and let us find out why. The process here you're looking at is calculate student GPA. I have here an output which is a student ID and another output grade details. I'm not looking at the logic at this point, but this is incorrect simply because I have two outputs and no inputs. This is called spontaneous generation. That means I made something, the output, out of nothing. So remember, processes need at least one input and they will produce at least one output. Taking a look at this example, calculate pay, I have an input, hourly rate, and I have another input, hours worked, but I have no output. And this is also incorrect because I need output. This is called a black hole. So things are going in and they're not escaping. Nothing's coming out, just like a black hole. Another incorrect example where I have a process called convert temperature, and as you might guess, it produces converted temperature as an output, but the input is time. I don't need time in order to convert temperature, let's say from Fahrenheit to Celsius or vice versa. So basically this is incorrect, and it's called a gray hole because the input that I'm using is not helping to produce the output. It simply doesn't make sense. Okay, moving on. Like I said before, the data store is a symbol that represents data that is temporarily saved in your system. Okay, and they are often translated later in the system as database tables. Okay, the symbol of the data store is this rectangle with a compartment on the left, again showing a unique number, and we use here, instead of just numbers 1, 2, 3 as in the process, we use D1, D2, D3 and so on. Again, the rules of the data store, as you see here in front of you, is that they must have at least one incoming data or data flow, sorry, and one outgoing data flow.